Welcome to this webinar on Fun with AutoCAD, brackets Map 3D. My name's Ian Robinson. I'm the infrastructure consultant here at grych. I've been doing this over 20 years now. I basically consult, I train, I present, I evangelise geospatial and civil engineering and BIM solutions to as many people that listen to me. I specialise with AutoCAD and Civil 3D and InfoWorks and vehicle tracking, of course Map 3D, recap for your point clouds, and also Navisworks and the Autodesk Construction Cloud as well. I work for grych, and we're a software developer and Autodesk Platinum partner, and we help construction and manufacturing professionals achieve their digital transformation goals by providing world-beating software solutions. We've got users all over the globe, and they're supported by over 700 BIM consultants, software specialists, and developers. We have a presence in every habitable continent throughout our extensive network office, but also through our partner program, seen here in the shaded countries on the map. So this is what we're going to do. We're going to start from scratch, a completely empty drawing, and we're going to finish up with this. Now, to get here, we need to do a few things. First of all, we're going to get some data, and we need some landform data, and we're going to place our buildings at the correct elevation on that landform data. We'll get some aerial imagery, and we can drape that onto the surface as well, so it looks a bit more realistic. While we're at it, we might as well have a quick look at some flooding, find out which buildings flood, and then of course we need the buildings themselves. And I'm going to be using master map topographic data and some height data that they also provide with it, so that we can create the buildings in 3D at the correct elevation with also the correct roof heights. So to do this, this is the list of what we're going to cover today, and I did this one mainly because a customer asked me how to do this, and in working out the answer I realised a couple of things. One, it's really great to visualise mapping data in a much better way in AutoCAD than boring lines, arcs and circles. And two, these steps are useful individual things that we can use in all sorts of different ways when you're using the correct version of AutoCAD. So it's well worth documenting. So we'll go through that list and we'll start with number one, which was, what is AutoCAD Map and how do I get it? Well, quite simply, AutoCAD Map 3D is just AutoCAD. It's AutoCAD with bells and whistles to help you do your job. So if you're working on planet Earth, and this is the variant of AutoCAD that works with real-world coordinates, for example, amongst other things that you'll see today. Now, you might be saying, well, I'm a building architect, do I need it? Well, probably not. But there's a version of AutoCAD for you as well. And that one will help you do your job. So you've got AutoCAD Architecture. We've also got electrical, mechanical, plant, MEP engineers versions. So there's also one for doing images as well, manipulating images. So before you go and download the AutoCAD that you've purchased, make sure you download the right one for your job. There's nothing removed from it. It just adds things that helps you do your job. Now, these tools that I'm about to show you are not available in vanilla AutoCAD, so make sure you do download Map 3D. But if you are a Civil 3D user, these tools are also in Civil 3D. To see them in the ribbon, you just change the workspace to Planning and Analysis. If you're using InfoWorks, all the FDO tools, Feature Data Object tools, are in there. So you can connect to the same data, you can view it there, but if you want to manipulate the data, which is what I'm going to be doing, then you'll need to use Map 3D or Civil 3D. So let's now talk a little bit about the data that I'm going to be using. So the first one is, there's loads of places you can get data from. If you have any questions, please just ask. But for this presentation, I'll be using some free data via the INSPIRE directive, the European Union directive that allows governments to share their data. The first one will be from DEFRA, or the Environment Agency. It'll be LIDAR data, landform. It's a digital terrain surface on a 1 metre grid. It was uploaded to the server in 2020, and we can all just go and download that free of charge. I'll also be using from the Environment Agency Flood Zone 2, so we can have a look at which buildings will flood. They're all free, as I say, but under the government open data license. So again, if you have any questions, please just ask. Now for the buildings, I'm going to be using Ordnance Survey Master Map. This is not free. You can purchase it from a number of resellers of Ordnance Survey data, or if you work in government or on behalf of a government, including local authorities, then you will have access to this data under the Public Sector Geospatial Agreement. Again, if you have any questions, please just ask. The first data set is the Master Map topography layer, and that will give me all the buildings, just a 2D polygon of the buildings. Alongside that, we also can download a data set for building height attributes. Now this comes in a form of CSV, or comma separated variable. So we're going to need to do a bit of work on that one to get it to work with AutoCAD Map 3D. And then finally, I'll get the aerial imagery from Ordnance Survey as well. And there are other providers and what have you, but you know, it's very cheap to buy if you need to buy it. But the same rules apply. If you're working under government license, then you can get that data. So first things first, importing and exporting geospatial data. That was an item on the list, and it's an item that Map 3D will add to AutoCAD. So let's just go ahead and have a look at that. This is AutoCAD. It's just plain old AutoCAD. There's all your ribbon with your standard AutoCAD tools. But of course, as I mentioned earlier, it is AutoCAD Map 3D. I mentioned it many, many times. So it's got additional tools. One clue is that down here, we can set it on the British National Grid. And in fact, you can set it on any coordinate system anywhere in the world. There's hundreds of them all in here. So it is Map 3D. Now with the workspaces, the AutoCAD workspace is 2D drafting. There's a maintenance workspace, which is a Map 3D, but for industry modeling. And then planning and analysis is your AutoCAD Map 3D interface. So you get a few extra bits in here. So we've got the task pane down here, which you can turn on and off at any time, even in the AutoCAD interface. Just use the command map W space, the word space, not the space bar. So MAPWSPACE. And you get some extra mapping functions here, but from here to the right, it's all just AutoCAD. There's no difference, you know, it's drawing lines, but instead of the first button being lines, it's going to be polylines, because that's what you're going to more likely use in Map 3D. If I go into the Insert tab, you can see there's a map import. So it's a little bit different because that allows us to import geospatial files, but the normal AutoCAD import works just the same, and you can make your own workspaces, as you probably all are aware. So there's my IWR map one. It's just slightly different, a few different buttons in different places, but essentially it's just AutoCAD. If you're used to using your commands, just carry on as normal. AutoCAD Map 3D is AutoCAD with bells and whistles on it. Right, importing geospatial files. This is just an area that I'm going to work on. We have just this area here. Want to bring in our mapping data just in this area here. I'll turn the map back off though, we don't need to see it. We can use a button, Insert, and you'll see Map Import, or you can just type the command. If you were to type import in the command line, you would get the normal AutoCAD import tools, and you'll see you can import PDF files, ProE files, MicroStation, Rhino, SolidWorks, all kind of engineering type files. But if you were to type map import, you would then get the geospatial version of the import tools. And you can see in here we can import Autodesk SDF files, which is spatial data files, or Esri shape files, map info files, they're quite common, tab files or MIFMID files. We can also do all the OGC stuff, so that's the Open Geospatial Consortium. So KML, for example, keyhole markup language, it's just a markup language like GML. We can import all of these as well. Now in this case, I have got some Ordnance Survey master map files, which is in a compressed GML format called a GZ format. So we're going to bring that in, but it's going to be too big for this area. So we can do some clever stuff as we're bringing it in. It's a much bigger area, that tile. We just want to bring it within this rectangle. So we'll hit OK. Now, one thing I have done in this drawing, all the layers are already set up. So I'm using the master map template. I don't know if it still comes with Map 3D. It used to anyway. And that has all the layers set up for master map. Now, with Ordnance Survey master map topology, you get topographic data. It's in one of these schemas in here. So when you do the import master map, all these layers come up here, which are basically to do with the schemas. So for all the different types of Ordnance Survey imports. So you've got address point, for example, or cartographic text. Well, all we want is, we want topographic area. So I can right click and deselect all, and then just bring in the topographic area. Topographic line is like the old landline product, if any of you are old enough to remember that. But we're going to bring in the topographic area. Now, it's going to land at the moment just on one layer, and I don't want that. So I'm going to click on there, and I can either put it on any layer I want, it'll all land on one layer, or I could say use the data fields, and it will read the data fields in that data, which you'll see in a minute. If you've never seen this before, you'll see the data fields. And the one we're going to use here is we're going to use descriptive group. That basically, if a line is representing a building, it'll be on a layer called building. If it represents a road, it'll be on a layer called road or track. So we'll use that descriptive group. Now, I mentioned this data is not just lines, arcs and circles, in this case just lines. It also has these attribute data in there, and you need to bring that data in as well. So that's this field here. You can either right click the header and it'll just bring them all in for all of them, or just right click here and you'll see you can use the input layer. And basically it's going to create a table outside of the geometry that sits within AutoCAD Map and reads it. You can see that table if I click on the ellipses. You can see there's the table, topographic area, and there's all the other ones. We don't need all of them, we just need topographic area. And if I select the fields, you'll see there we are, descriptive group. And there's things like change date and make, and a thing called the TOID. That's the important one, that's the topographic ID. That's the thing that we're going to link up later on. So we hit OK. So we're bringing all that data in as well. Up here in the top right, you've got your spatial filter. And it'll either just, if you say none, it'll just bring the whole file in, which is around 150,000 elements, which we don't need. You could just say current display, so whatever you're looking at, or you could just define a window. And I just want to bring it in around this area here. So we don't bring it all in, it'll be a much quicker way of doing it. Now, for the task I'm about to do, which is I need to do some data processing to allow me to attach building height information into here, and then I'm going to extrude, make the lines into solids and make them the height of the building data. Now, in order to do that, I need to make them lines, not polygons. So when it brings a building in, it won't be an M polygon, it will be a polyline that's closed. That's important for this particular task, but not necessarily important for all of your input tasks in here. That's it, that's all I need to do in here. So I'll just hit OK, and it will take about a minute and a half, maybe 2 minutes to bring them in. There might be about 50,000 elements in here. We'll find out in a second. There it is, it's coming in. Not sure how many objects there are. Oh, there we are, there's about 7,500 just in that area. It's coloured it up in here because of the layers I've put them on. You can see there, in that one there is a polyline and it's on the building layer. This one here, this is a polyline and it's on general surface and it's green. Okay, so that's all of the importing master map data and any geospatial data. The principles are the same, so you should have no problems with that. Now, to export any AutoCAD element, it doesn't have to be what I've just imported here, it can be any AutoCAD elements. We can use the export command, but of course remember, if we were to type export, we would get the AutoCAD version of that command, so IGES files, DGN files, stuff like that. But if we were to type map export, we will get the geospatial version of that command. And you can see here I can export to a shape file, I can export to MIF-MID files, OGC, even Google Earth files. If somebody says to you, can I have that drawing in Google Earth because I don't have any CAD systems, I just want to use it in a free tool like Google Earth, then the answer is yes. Just make sure you're using Map 3D. So let's do it. We'll do it to an Esri shapefile. That's the most common files that you come across. So let me export this. So I'm going to export it as buildings only. And we're just going to call this OSMM buildings. OSMM buildings, and hit OK. Now, Esri shapefiles are unusual. All the other spatial files work differently, but an Esri shapefile can only contain one of 4 types of geometries. It can either contain points, lines, polygons, or text. So if you've got a large Esri shapefile, you may see it broken up into these different categories. So if it's line work with some text, there'll be 2 shapefiles, one with the text in and one with the line work in. Any other export like Autodesk SDF will be just a single file like you would expect with something like AutoCAD. The advantage of using shapefile is it's almost like a de facto default, if you like, because it's a bit like the DWG. You know, if you're creating CAD drawings, DWG is owned by Autodesk, but it's pretty much the default throughout the industry. Everybody knows a drawing file. A shapefile is the equivalent of that in geospatial terms. Every vendor of software will be able to import and export shapefiles. Now, in our case, we're going to export them as lines. And we could export the whole thing, or we could have gone and turned all the layers off in AutoCAD and just shown the buildings, because in this case, I just want to export the buildings. We could have gone into AutoCAD and just turned the layers off, but you've also got the option here, which we can filter it and say, all you need to do is export the building layer, and it won't export anything else, it'll just export the buildings. There we are. So that's what the filter allows you to do. Of course, you can filter by selection using quick select in here, or you can just manually select whichever. Doesn't really matter. Now, the important thing is the data again. I mentioned it earlier. The data is always important. We need to select the attributes. Now, if I click on select attributes, you've got your normal AutoCAD properties here. So if, for example, you want the area of a closed polyline, you could export that as a bit of information. But the stuff that we imported into the geospatial from the GZ file to bring this master map in had its own attribute data, and it's called object data. So treat it like an attribute, but it's object data. It's data that's attached to the actual objects. And if I expand that, you should be able to see that topographic area table is in there. There it is. So I'm going to add that table. If I expand that, you can see all the different fields are in there. That also has the calculated area value as well, so we don't have to worry about adding that from the AutoCAD polygon polylines. So yeah, so just tick the data you would like to export. And there it is. It's going to export that data. On the option tab, there's not a lot you need to do here. Again, there's the coordinates in here. You can convert it to different coordinates if you want to do so. And the driver options on a shapefile is whether you're doing a 3D or a 2D shapefile. This is mapping data. It's all in 2D. We're going to make it 3D though. So let's leave it on 2D. And that is it. That will export. So it's going to export the buildings as lines with the data. Boom. Okay, let that happen. There we go. Didn't take long. Tells you in the command line usually how long it took. So let's have a quick look at that. 8 seconds. There we are. And it's exported all the objects. And there's only 3,124. So the original file, 150,000 objects. And to get to what we want, we've now dropped it down to 3,124. Which will save you a lot of screaming and tearing your hair out when you've got a big CAD file. let's go and test that file. So we can import geospatial data, but we can also just view geospatial data without importing it using a thing called FDO. I'm just going to open up any old drawing. I'll just open a blank drawing. And let me go and find that file. So just give me a second to get it up. So I put it into process data, shape files, building spatial. There it is. So these are the files. So a shape file comes with all these extra files in here. So if you were sharing this with anybody, you need to make sure you send them all. And it's very simple. The SHP file, that's the only one you need to deal with. That's the geometry, but it brings everything else in it. So the projection just tells us, the PRJ file just tells us what coordinate system we're using. The DBF file holds all that attribute information, the object data, and we can just view it. Now, there's a couple of ways of doing this. We can just simply drag and drop the shape file into any AutoCAD drawing, and it'll automatically connect to it. And you can see it's bringing this connection in here. So that's brought the shape files in with just the elements we've extracted, which are the buildings. Now, if I was to look at the properties of any of them buildings, just your normal AutoCAD properties, it's got your normal, you see it's called a map feature, and then we've got all these attribute data in here. So we've got this extra attribute data. I have got a preferred method of viewing it though. You can view it in a table here, this table. So this is now that same attribute data but in table form, so I can see it all much easier. And you can also select using that square and it will take you to the building that you wanted to look at, etc. And it's fully editable and all that business, if you want it to be. Obviously with mapping data you wouldn't want it to be editable, would you? And that's it. That's how you can easily view spatial data, but we can do much more than that as well, which I'll cover. So just as a temporary measure, I did do the full extract on this one as well. Let me get that up. There it is, the full data set. If I was just to drag that in, you can see it's much bigger. Look at the size of the file. You know, it's half a gig if you add all them together. It is 525 meg. Okay, so it's a huge file. You wouldn't dare import that. Well, you can actually, but it would obviously cause a lot of problems. It would take you a long time. There it is. There's all that data. Loads of information in there. But we don't have to do it that way. What we could do is we can also query the data. Now, if you've already got the data in, you can right-click it in the task pane and you can query to filter data, like so. Or, if I just delete that, and I will show you another way. I'll remove that layer. You can use the data connect to data tool, and you can see here there's loads of different ways of connecting to different types of data. So SQL servers, ODBC, we'll be looking at that later. SDF files, shape files. We've also got web mapping services. We'll have a look at that later as well. But in here, you can see that's that connection that I've already made by dragging and dropping. It automatically creates that connection. Now, I could just tick that, or go and find another one, just go and give it a name. I'll call it buildings, for argument's sake. And I could either go and find a folder full of them, or I can just go and find an actual file. So it is in here, and it is in process data, shape files, full data set, and there's the shape file. Notice it only shows the shape file, which is fine. And I can connect to it, so I'm creating another connection to it. But this time, rather than just adding the whole thing to the map, I could say, let's just add a smaller amount to the map. So I can say, add to map with query. And you know, when I dragged and dropped it, it just brought the whole lot in. Well, what I could say is, I could pick this query and say, look at the property, descriptive. Remember, it was called descriptive group originally. Shape files have a restriction on the number of characters it can use, so it does trim them down. But anyway, we know it's that one, descriptive. And we can just say equals. And we want to put in the word building. Now, if I spell it wrong, if I was to put in building like that, okay, and I try and validate it, it's saying there's a problem here. That's because you need to have a comma, an inverted comma above it. Now there it's saying, look, the expression's valid, but I've spelt it wrong. So what I'm going to get when I hit OK is nothing, because there are no bits of data called building spelt that way. So the best way is not to do it that way, is to hit that little green button there, and you can now go and find all these values. So if we go to descriptive and hit the green button again, it will list everything in descriptive, and there it is. So I now can just go and pick from this list, and if I double click the word building, it'll fill it in, it'll put the little inverted commas around it, or comma around it, and it will spell it correctly, okay? And I can validate and it will say, yeah, that's right. Anyway, that's it. Just hit OK and it will bring the buildings in. Just the buildings, rather than the whole thing. There it is. And we can see now there are just buildings in here. We can colour them any way we want as well. If I select in here and go to style, we can just say, let's change them from that purpley colour. We can make them whatever colour we want. I don't know, red. You know, and we've got red buildings. We could also have done a spatial filter when we did that as well. And as I mentioned earlier, we can do spatial filters or any filter after the event. If you wanted to do one after the event, just right click, query to filter data, and it brings that same window up. There it is, descriptive equals building. Now I'm going to do location on map, touching any part of a rectangle, and I'll just draw the rectangle. If there was one already created, I could have selected it. There we are. And it's going to do both of these now. So I hit OK. Oh, I need to do and, sorry. Let's just do and location within there. Hit OK. And that will bring back just the buildings that are within that boundary or touching the boundary. You can see that that's the big church in Exeter, and it was just touching that boundary. Okay, and that's it. That's us bringing our spatial data in. Next, we're going to look at how to connect to this text file using ODBC, and we're also going to have a look at using Map Explorer to alter the properties. Now, with building heights and the Ordnance Survey, they supply it as a separate CSV file, comma-separated variable. If you open it up, it'll look something like this here. Most Windows machines, though, will open CSVs in Excel. It doesn't mean it's an Excel sheet, it's just a CSV file, but Windows says when you double-click a CSV, open it in this program. There were some limitations, there are less limitations these days with these. Now, the thing to note, if I just close that down, if we have a look at the TOID in our mapping data, so that's the topographic ID, each building has its own unique topographic ID. And you'll see that these don't exactly match. So you've got 5000 at the beginning, or 0001 at the beginning, or some of them will be 1000. There'll be all these different formatted ones, yet and here they all have OSGB in it. So we need to do a little bit of manipulation to get that started. Now, if you're an Excel whiz, I'm sure you can work out how to do that. I've got to be honest, I wouldn't say I'm an Excel whiz. And a quick and easy way is I can just do it in two different formulas. I haven't bothered merging them into one formula. Yes, we could do that, and it would look very complicated, it would look very impressive, but I've just left it in two different formulas. So basically I've just said replace them first three noughts. Okay, that's essentially what that is doing. If I was to just type in here equals replace, you'll see there it says it replaces part of the text, and then you put in your start number, the number of characters, and what new text you want in. So I'm going to start at 1, the first 4 characters, and I'm going to replace them with 0000. Okay, so that's all that one will do. So it will take all of them, and I will just double click, and you'll see they're all now up there. Now, the other problem we have is some of these are 16 digits long and some of them are not 16 digits long. So how does OS handle that in the mapping data? And you'll see what I've done here is I've created a formula. If the length is greater than 16, then just use the first 16 digits, or the last 16 digits. If it's not greater than 16, then just use that code. So again, we can simply just double click that, and now they're all 16 digits long, and that pretty much will match the OS. There might be the odd one that we need to kind of handle separately, but we can maybe look at that individually. But that's quite simply the easiest way to work with this text file. So all I've done there is I've just created this map ID, and I've used that formula to give us that, and then I've copied and pasted it as just text. That's all I've done. Basically just copied that, pasted it in here, but instead of doing a just paste, I've pasted it just as text, so the contents, just to make it easier. Now, I also find that sometimes in certain Windows programs, certainly earlier than Windows 10, maybe Windows, was there a Windows 9? I forget already. Windows 8. The drivers for connecting to this is a bit iffy, and we use a system called ODBC, Open Database Connectivity, and we want to connect to this. Now, what I've found is that it's a lot easier to work in here. Okay, so this is just Access. So all I've done is I've just imported that into Access. It gives us a primary key, and we can use this information. So the maptoid, so toid map, should I say, that's the column that's going to match the data in my drawing here, this column here. All right, so what we want to do now is we want to bring these two together, and we can do that by simply connecting to that database. Now, before we do that, we have to create an ODBC link, and I've already done one, but I'll do it again. All you do is in Windows, ODBC. It's very important you pick the 64-bit one because we're using 64-bit software. If you accidentally create it in the 32-bit software, it just simply won't work. Okay, so I've created one there called SX90 Building Heights, which I've already done. I'll show you how to create it again. So if I just add another one, and I will use Access drivers, so Microsoft Access. Now, you can use text, you can use CSV, you can use Excel. If you are using text and CSV, you do have to tell it what each column is, though. It's a bit more complex, whereas here it's a bit simpler. So I'm going to use Microsoft, hit Finish. We'll give it a name, and I'll just call this one SX90 Building Heights _2. And all we do is go and select the database. So we need to go and find that database. So that will be in my work folder, and in here, and in here, and in data, and in OS. Oh, it'll be process data, won't it? Process data, building heights. Okay, so there is my Access database that I have here. That's probably worth me shutting this down before I actually do it, just in case. Some databases get locked, some don't. You're all right with Access, but you're not so good with Excel. Well, are you all right with Access? Not really. So let's just do it and hit OK. So that is creating this ODBC. In the options, there's not a lot we need to do in here. We can tell it to be read-only if we want to, and exclusive and all that sort of stuff. But that's it. That's your ODBC connected there. All right. So let's go and connect to that. So we go Data, Connect to Data. And it's an ODBC link. And we'll just call this one Building Heights. And we'll go and find it. And there it is, the one I've just created now. Select and test the connection. Always, on all of these, it will ask you for a username and password because some databases are locked, aren't they? We don't have any passwords on here. I mean, we could have created one in here, couldn't we? If I configure that and go to Advanced, we can create passwords and stuff like that, which we're not going to do. Okay. So if there's no password, just hit Login. And it says, okay, there's a few tables in there. Which one would you like? And I want the formatted one, the one that I created called formatted. The ID needs to be selected. It's already done that for us because we're using the Access database. If you're using a text file, you need to say which column is the ID. In databases, you always have to have a unique column. That's it. So we'll connect to that database. Now, we can't add it to the map because there's no X and Y on it. It's just a load of data. But what we can do is we can connect it to this database by connecting that column to the toid map, or map toid, whichever way around I called it, okay? So to connect it, oh, hang on. To connect it, I'm going to use the drop down here, and we'll create a join. And I'm going to pick my OS data and attach it to that formatted data. We'll pick the toid in here, and we'll pick the map toid in there. And we'll tell it to keep all the records on the left, and we're going to match 1 to 1. Hit OK. Let it rebuild. And in here, you can now see we've got this extra data on here. All right. So all this data is attached to each of the buildings. So if I was to go in and just view any one building, let's just pick this one randomly, you can see there that it tells us that it has an absolute height minimum, 31.2. So that means the base of that building is at 31.2 meters above sea level. It has absolute H2. That means the eaves of the building are 42.6 meters above sea level. An absolute max, that means the highest point of that building, it might be the tall chimney stack or something, is 48.5 above sea level. And then you have these relative ones. So relative H2 is the height of the eaves as compared to the base height. So from the bottom of the building to the eaves. And you should be able to work that out because the base is 31.2 and the eaves are at 42.6. And the difference between them two numbers is 11.4. And then you've got the relative H2 max, the relative height max, 17.3, and that's the highest point on that roof, whatever that is. It's remarkably, it's surprisingly difficult to work out how high a roof is on a building. Now, you go out and look at your house, it should be fairly simple. Most houses and stuff are fairly simple. But go and look at a church and say, what's the maximum height of that roof? Is it the top of the spire? Which part of the building are you going to take, etc.? It's not a simple question. And that's it. We have that data now all linked together. Okay, so now we have a shapefile that's linked to a text file, but what I want is an AutoCAD line, because we're just working with AutoCAD here. We're not gonna, this might be going into LT in the future, for example. What I want is an AutoCAD line with these attribute data. So what we can do is we can export this as a shapefile, or a SDF file would probably be easier, and then import it as an AutoCAD file. Now, I would like this to be easier because there is a tool in here in the output, current map to DWG, and you can just click on that and suddenly all these become polylines. Just end up with another drawing as polyline. The downside to that, though, is it will not export this data, and I want that data on the polylines. Okay, so probably the quickest way, like all things, there's lots of different ways of doing this, but if I just right click and just export it to an SDF temporarily, so I'll just put it in process data. There we are. Here's one I've done earlier, but this one's called OSMM Buildings SDF. Okay, and then we're going to start a new drawing. We're going to import, so map import. And in here, we're going to pick SDF this time, so Autodesk SDF. And that will be in my process data, and there it is, the one we just created. So we're going to import these. We can put them all on one layer if we want. They're on this layer here, that's fine. But we do need to bring this data in. Remember, we must use this input layer. So you can see in there, we need to make sure we've got this data in. And look, it's bringing through that extra added data as well. So the building heights relative H2, for example. All right, so it's going to bring that in as well. So I think we're good to go on this. We don't need to do a spatial filter. We don't need to tick that this time because we created them as lines, didn't we? So they're not polygons anymore. So I think we're good to go on this one. So we'll hit OK. Zoom extents. There's my buildings. Let's just randomly pick one and check its properties. And there's the data and there's the building height. All in here. OK. So there's the relative H2, 8.8 meters tall, whatever that building is there. Brilliant. Right. OK. Let's save this drawing because there's more we can do in this. So I'll just save this drawing as processed, and I'll just call this one CAD buildings with building heights. And then we'll move on. Okay, so now we have our drawing here in CAD format, all flat 2D, and they have that attribute information on it. We can actually alter them properties in AutoCAD without doing any spatial stuff. And we do this in Map Explorer. And what we can do here, if I go back and get that, is we can just drag the CAD file into here. And this will connect to the CAD file, and then we can do spatial queries and property queries and all sorts. If I was just to right-click it and I was to do a quick view, and I could also zoom extent of it, there it is, that's what it is. And if I pick on it, it looks like it's a block. It's not actually in the drawing. If I did a regen, it'll just disappear. We haven't brought it into the drawing. So what we're going to do is we're going to query into the drawing. And the first thing is I want the whole lot, don't I? But I could do a location query here, but I don't. I'm just going to go location all. And then, okay, so it's going to bring them all in. And now I want to alter the properties. So we'll go and alter properties. And the first thing is I want to change the elevation of the polyline. So I want the bottom of the building to be on the level. And if you remember from the data that I added to it, that will be absolute minimum. So we'll click in elevation, and we'll use an expression. Let that open, there it is. And we'll go and find that object data, there it all is. And we're going to say that the elevation is the absolute minimum level. And we're going to add that in. And then the other thing we can do is we can change the thickness of the line, can't we? So if I then say thickness expression, and that one will be from the base of the building to the eaves. We'll do it to the eaves. So that will be relative H2, and add that one in. And then hit OK. Now in this way, we can either preview it and have a look in preview mode or draw it. So it's often worth just previewing it and then rerunning the query. It'll remember what you did last time and then do it. I'll just go straight and draw it though this time and make sure that that is ticked, that it will alter the properties. Because if you preview it, it won't alter them. So execute query. There they are. And if I spin that into 3D, we should see the buildings. They're all at different levels because they're at the height of bottom of the building, and they are also, they're polylines. We have a look, it's just a polyline, but the polyline has a thickness. Now what I want to do is I want to make them into solids. Now before we convert them to a solid, they have to be closed polylines. Now I know right at the beginning when I imported the master map data, I said make polygons closed polylines. However, in the process of importing them into shape files and exporting them and into SDF files and exporting them, there won't be closed polylines anymore. Let's just double check. And if we see there, closed, no. So what we have to do is close all the polylines. So we'll just say yes. Say no to that. Oh, that comes up because all of these, it's still part of the query here, and it means that if I change something here, I can go and change the original one, the original drawing. It allows you to bring drawings, a single drawing into multiple other drawings and all edit that one drawing. It's quite clever, really. But if I just detach it, that will stop that message coming up. I might get another message saying it's not going to do it. There we go. Get another message up saying everything's detached. These are now treated as new objects. Okay, so I'll clear that message. Right, now let's just do that again. And I'll say make them closed. There they all are, closed polylines. So now we're going to use a command to convert them to a solid. And the command is CONV, it's conv to solid. There it is, TOSOLID. Give it a second while it converts them. You can see it's working away. Doesn't take too long. We've got a fair few buildings. There was about 3,000, wasn't there? Over 3,000 buildings. Now these should all be AutoCAD solids now, which they are. If I change that to, let's just go to shades of grey. There's our solid buildings, all at the correct height. Very nice, eh? Right, now finally, I'm going to show you how to add that ground data, the image, and also the flood data via FDO. So we're going to do a little bit more on that one. And then we'll be able to show you all in 3D at the end. Now we have our 3D buildings, let's add some other data. Oh, this is quite nice down here. We can switch between 2D and 3D. And it automatically changes the view and everything for us, which is quite nice. So let's go and add in some ground data. So we'll connect to some ground data on this drawing. So in this case, we're going to bring in the LIDAR data. Let me just show you the LIDAR data. So from the Environment Agency, I've got this LIDAR data here, which we have. So I will just go to that folder there. So if I go add a raster image, remember LIDAR is raster data. Go and find it, and we'll go straight into that folder. There it is. Open it, connect, add to map. And there is the LIDAR data. I'll just shut down the property window, I don't need that. We can actually add these buildings into here so they're easily turned on and off as well. And we can also change the order that the buildings are in by adding them in here. Okay, so in the data, instead of connecting to data, we can just add drawing data in. So if I go in and say add drawing layer, I can pick my buildings. And now they're in there as well. You can see they're on the top of that. And we can turn them on and off from here, which is quite nice. We could style this up if we wanted to. We can just add a theme. So I'll just go add a theme, and we'll use a palette, and we'll use the National Map palette. I quite like that one. And okay. Like so. Now if I spin that into 3D, you'll see the buildings are all sat on top of it, which is rather nice. Okay, might want to change the colour of the buildings. They're a bit dark, aren't they? That's a bit easier. So now we know the buildings are at the right elevation, sat on the ground, like so. Let's do a little bit more. Let's go and add an aerial image onto here, okay? I should have named the last one, I just called it raster 1, but we'll call this one aerial. And we'll go and find the aerial image. So if I go back to the OS image, there it is, ECW. Let's keep that expanded, connect, add to map. Sometimes I get this message when it worries about the coordinates. It's because the coordinate was missing on the source file. Which is essentially my fault. So I'm just going to go on. Essentially, when I added it, I didn't tell it what coordinate system to use. You will find that. I mean, basically, if I quickly go in here, this XML file will tell us the coordinates that it's going to use and things like that. And sometimes that's missing. You can see it's Ordnance Survey, but yeah. So all I need to do is just tell it what coordinates I'm running on. So if I just go back in here and double click where it says coordinate system unknown, and in here find OSGB. It's quite handy these sometimes happen, isn't it? So you can see how we fix them. Immediately that's fixed the problem. And there is the aerial imagery. Now when you add aerial imagery in 3D, it automatically drapes it. If you're using the FDO to import it, it will automatically drape the imagery onto that, which is rather nice. And then lastly, we were going to see which of these buildings flood in flood zone 2. I'm going to drag that above there so you can see the buildings above there. So let's go back in to data, connect to data. And we're going to add in a shapefile because I've got flood zone 2 as a shapefile. So let's go and have a quick look at that. EA flood zone 2, there we are. Now it's a huge file. It's 837 megabytes big. So it's a massive file. So rather than bring the whole file in, because it's the whole of England is this file, we're going to do a spatial query. So we'll go and add the shape in. We'll call it, what are we calling it? Flood zone 2. Flood zone 2. We'll go and find that file. And we'll go into EA and flood zone 2. And there it is. Open. We'll connect to it. And again, make sure we use this query. And we'll do location on a map, rectangle, and then we'll just pick this area here. Hit OK. And that will bring in flood zone 2. There it is. Yellow's not a great colour, is it, for flood zone 2? So let's go and change its colour with the style editor. I'm going to make it blue. Let's scare people. We can add the transparency to it as well if we want to. Tell you what, let's make it a bit darker blue. Oh, I don't know which one I like. Let's go with that one. A little bit of transparency. You can just drag that up. It's a bit weird. There's no bar or anything, but you can just drag it up to make it transparent. And we can make the boundary red as well, so we can see a nice thick red line where the boundary is. And there it is. Now with shape files, it will also drape them on the surface. So if I spin this into 3D, we will be able to have a good look. And that is flood zone 2. So we can see which buildings are in flood zone 2, which is rather nice. Let's go back into 2D. And one other thing we can do is we can connect to web mapping services as well. I'll just turn flood zone 2 off. Now, web mapping services are a way of connecting to somebody else's database and viewing their data directly on your model. So let's go and have a look at one of them. So the website I showed you, the DEFRA website where I got flood zone 2 from, things like that. We can also get other data sets. You can see here, risk of flooding from surface water at a depth of 0.1 annual % chance, 1 in a 1,000-year flood. And we can just basically link to the WMS file. So rather than downloading the data as a shapefile and then importing it, we'll just go copy link to clipboard. And in our data, connect to data, we will find WMS. So that's a web mapping service. That's like a raster image. And web feature services are like vector, and web tile caches are to do with tile caches. So I'll just flood depth 1, 1. Oh, I'll do 0.1. 0.1. Okay, and all you do is paste that web address. Connect. Again, it's open license, so there's no login. Just click login. And this, you do have to make this bigger for some reason. Not sure why, Autodesk, if you're listening. And these are our data sets. What we want is the actual flooding data. So I'm going to add it to the map. This is for the whole of England, so it's a huge, huge data set. There is the flood data for that. And it's, as I say, the whole of England. Basically, it's a tile cache. So as you move across, so it's a cache. You can see it will give us the flood data anywhere we want. Press the wrong button there. Aerial. Put the aerial map on so you've got some referencing here. There's clearly a river running down there. Unless it's a really, really badly flooded road. And there we go. Our flood data for anywhere we want. So that's rather nice, isn't it? We'll turn that map back off and we'll finish there, I think. Let me just go back to my drawing. You can navigate using this, by the way. You know, if you're a Civil 3D user, you'll be used to navigating via the task pane, the tool space in Civil, task pane in here. I can right click and I can zoom to the extent of any of these models in here. So yeah, rather nice. 3D buildings, flood data, and if you've got plain AutoCAD, you can do very nice stuff like that and don't buy buildings here. Cool, okay, thank you. And that's it. I'm hoping you all enjoyed that. If you have any questions, please feel free to ask them. And thank you very much for joining me.